Welcome to the physics class. In this video, we are going to study about graphs in kinematics. So first, some general points in graph we will see. So frequently asked graphs in kinematics are ST, VT, AT, and VS. So ST is displacement time, VT is velocity time, AT is acceleration time, and VS is velocity displacement graphs. Now equations between x and y will decide the shape of the graph. So a linear graph will look like this. A quadratic graph will look like this. So that is how the equation between x and y will decide the shape of the graph. Now instantaneous velocity equals v equals ds over dt equals to slope of displacement time graph. Now fourth point, dz, if dz equals to y dx, if there is a equation dz equals to y dx, then integral dz y dx integral y dx will give us, will be like this. So displacement is equal to velocity into time, we know that. Dx is equal to v dt, and if we integrate both sides, we will get s is equal to integral v dt, that is area under vt graph with projection along the t axis. So that is how we get area under vt graph with projection along t axis. Now one dimensional motion can be classified as following four types: uniform motion, uniformly accelerated motion, uniformly retarded motion, and uniformly retarded and then accelerated in opposite direction. So we will study each of these cases in detail now. The first is uniform motion. So in uniform motion there is no acceleration, so acceleration velocity graph will show us a equals to 0, and acceleration time, just let me check this one. So this should be acceleration time. Yes, so this is acceleration time graph will give us acceleration is equal to 0 in uniform motion, and acceleration time graph, if v is constant, then we will have this is equals to v is equals to constant. This type of graph will be there. Now in displacement time graph, in uniform motion we have a straight line, that is a linear line, and if there is a displacement traveled beforehand, some displacement is traveled already, then we have displacement is equals to s naught. S naught is the value of the displacement traveled plus vt. Now we come on to the second case, uniformly accelerated motion. In uniformly accelerated motion we have a uniform acceleration, as you can see in this graph. In vt graph we can see v equals to at, when we know that v equals to u plus at. When u equals to 0, then we get v equals to at. So that is how we get v equals to at graph. Then if we have u, then our graph will look like this: v equals to u plus at. So this is the u that is already present. Now s is equals to x is equals to ut plus half at square. So this has a square term, so this will imply that we have a quadratic equation which is passing through 0, because when we put passing through 0, because when we put t equals to 0, we will get s is equals to 0. So that is how we get a parabolic line here in displacement time graph. So in this is also a displacement time graph. In here we have s is equal to s naught plus ut plus half at square, where s naught is here. S naught is here. This is pretty simple. Now after that, in uniformly retarded motion, retarded means that we have a negative acceleration. We are having an acceleration, but it is in the negative direction. So I have made a line here. This is the AT graph, this is the 0 point, and we have negative acceleration here. So this is in the negative direction. Acceleration is in the negative direction. In VT graph, we will have u initial velocity, which will be decreasing because it is being retarded, and which we will get a final velocity v equals to 0. After that, coming to displacement time graph, we will see that first the slope is high, and then the slope becomes low. So that implies that we are having a retarded motion. Now after that, uniformly retarded and then accelerated in opposite direction. This is the fourth case. So the example of this is, suppose I take a ball and drop it down on the floor. Then what would be the acceleration acting on it? It would be gravity acting on it. That would be acceleration of 9.81 meter per second square in the negative direction. So that is why I have drawn AT graph here, acceleration time graph here, and there is a acceleration of minus 9.81 meter per second square. So motion is taking place under gravity here. Now coming to next graph, that is VT graph. So velocity time graph of a retarded motion will be look like this. Initial velocity u will be decreasing, and after an time the velocity will change its direction. That is, it will take a U-turn, and it will go on the opposite direction as shown here, in the negative direction. Negative direction means that it is taking a U-turn. Now displacement time graph. Displacement time graph will show like this. We will have a first a slope like this, and then it will decrease, slope will decrease, slope will come to 0. Slope will come to 0, and then it will be in the negative direction. Slope will be in negative direction, and here it is positive. So slope has become from positive to 0, then to negative. So that is how the displacement time graph works in uniformly retarded motion and then accelerated in opposite direction. So first the object is being retarded, and then it is being accelerated in the opposite direction. That is how this graph, or these three graphs work. So these are the graphs that are there in kinematics. These are the main graphs that are there in kinematics. There could be some more examples, but I have covered these graphs in this video. So that was all for today, guys. So if you have gained some knowledge from this video, please do like the video, subscribe to my channel, and share it among your friends. Thank you.